So hello future achievers. Now today we are back. We are going to start the next session of unit and measurement, and today we are going to see about the dimensions. That is a very favorite topic of our any competitive exam. In previous class we have seen about the what are the physical quantities and what are the types of physical quantities we have seen, and then we have seen about the derived physical quantities and the supplementary physical quantities, in which we have seen the two quantities, that is radian and the steradian. Now today we are going to cover about the dimensions, like what is my dimension analysis and what is the dimension. So let us start with the dimension analysis today, because that is going to be the very important. So we have to start. So let's start. First thing is, what is dimension? Okay. So dimensions basically they are basically the powers. Simply the dimension means they are the powers. So they are defined as a power which are raised to the derived physical quantities to their fundamental physical quantities which are used to represent that derived physical quantities. You are not able to understand, I got that. So simply you understand, it is the power. Basically let me first write the definition, then you will better understand. It is the power to which the fundamental unit are raised to represent the derived units. Clear? So these are the power to which the fundamental units are raised to represent the derived units. Okay, so they are basically the powers. What? They are powers to which the fundamental units are raised to represent the derived units. So basically dimension means powers. First thing, it has to be very clear. Dimension means powers. They are nothing else. For example, let's take one example. For example, let's take force. Okay. It is defined as mass into acceleration. Basically mass is what? Mass is kg. And how we write kg? Okay, before that let me tell you one thing. Then I will tell that, and you will better understand. See here, and you have to remember this, that is very important also. Suppose we have basically 7 fundamental quantities. First is mass, second is length, then time, then temperature. Okay, then we have temperature, then we have luminous intensity, so we have length, mass, temperature, luminous intensity and current. Okay, and then we have mole. So for this the thing you are going to use is mass. For this you are going to use L. For this you are going to use T. For this you are going to use either K or theta, any one of them. For this you are going to use CD. Okay, for this you are going to use either A or I. For this you are going to use mole. So let's come here. Mass is kg, acceleration is meter per second square. So I can write like this now. Mass is kg, that means m, into meter is length, divide by, that is, this is divided by what is t is time, whose power is 2. Now just write it in a proper manner. So it is m l t minus 2, correct? So what is the powers are there? If you see, what are the powers? Here the power is 1, here the power is 1, here the power is 1, here the power is 1. So what we have got finally, that is m to the power 1, l to the power 1 and t to the power minus 2. So what are the dimensions? So dimension is m1, l1 and t minus 2. Means dimension, these powers are, so the dimension of for the force is m to the power 1, l to the power 1 and t to the power minus 2. That is going to be the dimension. Clear? Till now anyone have a doubt, just note it down and just read it once, and then we are going to just start the numerical only, because after that there is a no theory. Okay, just numerical is there. So first you have to understand all this thing. So just revise it once time and just go through this. If you have any doubt, ask me please. So I think no one has a doubt, so let's go further. So let's take some example and let's find the dimension of those examples. Let's take refractive index. Okay, so refractive index, you know what is refractive index? It is equal to what? C by V, correct? C by V, that is speed in light, speed in vacuum divided by speed in light, speed in vacuum divided by speed in a medium. So what is the unit of this? It will be C. C is meter per second, so I can write it as meter means length and per second means t to the power minus 1, so I can write it as t to the power minus 1. If no one has understand, just I will expand it, then you will better understand. This is meter per second, clear? This is also meter per second, yes or no? Okay, so from here I can say this will be my L into t to the power minus 1, because for length we are going to use L, and for second we are going to use t, correct? Similarly for here also it will be L t to the power minus 1, correct? So from here what we will finally get, this will be cancel out with this thing, clear? So what we will get? We will get dimension as m to the power 0, L to the power 0 and t to the power 0. Means my coefficient, my refractive index has no unit, no dimension. Okay, it has no unit as well as no dimension, and that we also know that the refractive index has no unit and no dimension. Clear? Any doubt? Okay, let's take another example also. So next example, you can take universal gravitation constant. Universal gravitation Okay, constant. So if you talk about universal, we know that formula. Maybe some formula you don't know, but don't take stress. We will learn all these formulas by as we go further in the subject. Okay. So force is equal to G into M1 M2 by R square. This is the formula. So from here you can write G is equal to what? That is F into R square upon M1 into M2. If you know the unit, you can easily find the dimension. See, what is the unit of force? Kg per second minus 2. What is the unit of radius square? Means length square, or you can write meter square. Simple. What is my M1? That is kg into, that is also kg. So 1 kg will cancel out. So it will finally become how much? M minus 1, because kg will go above, and this will become how much? L cube and T minus 2. So that is a dimension for G. Okay. So that is a dimension for G. Clear? Now next example, let's take one more example. Let's take Planck's constant. Okay, let's take Planck's constant. So we know energy is equal to H into mu, where mu is the frequency. This is frequency. And I think you remember C is equal to lambda into mu, where lambda is wavelength. Okay, so from here you get energy as, an energy E is equal to H into, what is mu? C into wavelength, correct? What is the unit of E? Energy. Energy is kg meter square second minus 2. Okay, what is C? C is meter per second. What is wavelength? That is meter. So from here, if you cut everything, this will cancel out, and this will go there. So it will become H is equal to how much? Okay, so it will become kg into second minus 1, that is ml0 t minus 1, correct? ml0 t minus 1. Any doubt? So this is the way you can find the dimension of anything. Dimension analysis, do the dimension, and you can find easily the dimension of anything. Just if you know the formula, then it is nothing only. It just you have to simply apply the thing and you have to find the thing. Clear? That is, no one is going to ask. Just for this, I just tell you how to solve the. Okay. Okay. Now next, we move further. Let's take one more example. Let's take example of Boltzmann constant. Okay, let's take example of Boltzmann constant. Okay, so there is a one formula, if you remember. If you know, maybe you have a study in the chemistry. If you don't study, we will learn. Okay, so PV is equal to KT. That is a ideal gas equation. Okay, so from here I can say my PV by T. What is P? P is a pressure. Pressure is what? Force upon area. That is force volume by area. So what is force? We have seen that is ml T minus 2. Now you can directly write, okay, V is volume, so L cube, meter is L cube. What is A? A is area. Area means length square, so L square. What is my temperature? That is K. So from here we will get what? This thing will be cancelled out with this thing, and one power will be gone here. So we left with M L square T minus 2 and K minus 1. This is the dimension for Remember this K and this K is different. Okay, this K is Boltzmann constant. This represents Boltzmann constant. This represents temperature. Okay, in Kelvin. Okay, so that two are different. Okay, or it is better you write one more. We do one more thing. In spite of this, you can do write this. So to avoid the confusion. So there will be no confusion. T minus 2, theta minus 1. Clear? These are the some examples you can take and you can find the dimensions, no issue. Okay. Now then go to the let's move to the next topic. There is a one very important case. You have to remember this formula. Okay, that is most of the time they directly ask the dimension of that is coefficient of viscosity. Coefficient of viscosity. Okay, that is a coefficient of viscosity. First you have to tell me what is let me tell you the you have it is eta A dVv by dz, where eta is the coefficient of viscosity, F is a force, A is area, dV is change in velocity, dz is change in distance. Now you find where what is the dimension of eta. Just you solve this and write the answer in your notebook. So what is the value you will get? If you have solved, then eta will be equal to ml minus 1 t minus 1. That is the dimension of this eta. It's very simple. What is the dimension of force ml minus 2? What is the dimension of area? And this will be how much? And this will be how much? That is dz, means the height. So it will be again length. So from here if you solve, what you will get? L square, that will be go here, and t, that will be go here. So finally you will get the eta is equal to m L minus 1 t minus 1. Okay, clear? Any doubt? These are the some of the example. Now just note down very important thing, and one time one question has also come in the exam on this thing. Just you remember this thing, that is a very important. It is a very important result, you can say. Okay. Okay. What is that result? Remember this. The result is very important, and the result is the supplementary quantity has unit but no dimensions. What are the supplementary quantities we have seen in the last class? That is, one is radian, and another one is steradian. Clear? So these two are the quantities which has a unit but no dimension. There is a no dimension is there for them. So can I ask you one statement? Can there will be any physical quantity with no dimension, with dimension and no unit? So answer is no. Remember, there cannot be any quantity which can have a dimension and no like okay. Okay, so remember that there can be a physical quantity which has a unit but no dimension, but there cannot be any physical quantity which has a no dimension but can have, means with any physical quantity with a dimension but no unit, this cannot be possible. If it has a dimension, then it should a unit also, that is necessary, but it is possible that there may be some unit which some physical quantities that has a dimension but no that has a unit but no dimension. So let me clear in simple language. If there is some physical quantity is there and if it has a unit, okay, then there may be chance that it can have a dimension or it cannot be have a dimension, and the example is this supplementary quantities. But if you see, so there is but that reverse is not possible, means if we have a dimension, that means we should always have a unit also, then only we can have a dimension. Okay, so I write this reverse situation also. Can there will be any physical quantity with unit and no dimension? Answer is yes. Yeah, and you can see here they are radian and steradian, they have a unit but no dimension. Clear?